Hello and welcome back to episode number 2 of my world map tutorial series. In the last episode we left off with our very basic jumping parkour here created, and we already placed 2 target points in our map, the lower right and upper left corner, that I use for calculating the width and height of our level. Today we will deal with drawing the actual map texture, which will represent the level and then show it in game. The question we're facing right now is how do you draw an accurate map of this level? And the solution will be 3 different steps. So the plan is that we first render a top-down view of the whole world here. Then we will export that and import it into an image manipulation program like Photoshop or GIMP. I'll be using Photoshop for this video. And the last step would be to draw over the rendered image and import that new texture into Unreal. Alright, for the first step we need a camera that has to be positioned in the very center of the level, facing downwards to render the level, and what the camera sees should feed into an actual texture. So let's start with creating that texture. We will add another folder here for this and call it render target. Render target is just a texture which is based on what a camera sees. Let's go in that folder, and here we will right click. Then go under materials and textures and select the render target. So hit that button here. Let's call this the world render target. And then we'll open it up. Currently it's just black because there is no camera that feeds into this texture. However, we've got a couple of settings here. So the size in X and size in Y. This will be the resolution of the image we will draw over later. So let's make that very high res. So 2048 for X and Y. Remember from the last episode that our world is an exact square, so the width equals the height of the map. That is why we use the same value for X and Y here. If you're using a different shape for your world, you would have to adjust the settings then. And the other setting that is important here is the render target format. Currently that's set to RTF RGBA 16F, so 16-bit image. Band that here and we will choose RTF RGBA 8. So an 8-bit image with the red, green, blue and alpha channel. Usually that is the default when working with an image manipulation program, so that's why we choose it here. And then let's save and close our world render target. Next step would be to set up the camera that renders the world. So let's go into our world map system folder, into actors, and right click here. We will create a new blueprint class of the type actor and call it BP_world capture. Let's open it up. We only need one component in here, so just look for a scene capture component 2D and add that onto your default scene root. We can just call that scene capture. We want a top-down view, so our camera needs to face downwards. So simply rotate it by -90 degrees in Y. Let's go to the projection category. Currently that's set to perspective, but we want a 2D view. So let's change that to orthographic. And once you've changed that setting, you get the ortho width here. So the amount of units that this camera sees. Later we need to change that to match the width and height of our world, but we will script that behavior. So we can just leave it at the default right now. If you go to the scene capture, you need a texture target, so output the render target. And here you can just select the world render target we just created. It's asking you for a capture source. Currently that's set to scene color in RGB and the opacity in alpha. We will set that to scene color HDR in RGB and the scene depth in alpha. Then there are a couple of things that we don't want to see on the rendered image of our world. For example, the characters or some post-processing effects. To turn things like these off, you just go to scene capture and hit the show advanced, because then you will get a list of show flags, general, advanced and so on. Let's expand these. We will start with general. So first off, we don't want to see decals, and same goes for fog, so we will disable these two. Also particle sprites, so visual effects, and skeletal meshes, which include the character. Then we'll go to advanced, and here we will turn off the paper 2D sprites and the render text. Go to post-processing. Here we will just turn everything off. Then I'll go to light types and turn off the skylighting. Same thing goes for ambient occlusion and dynamic shadows. Then for the lightning features, you can leave these on. And for the hidden show flags, we will turn off post-processing. What you could do is try to drag this BP world capture into your world and put it at the exact center of the world. However, that would be tedious work, so we will make this actor do that for us. Let's go to the event graph, and we need two variables for that. To figure out the center, we need to know about the upper left and lower right corner. So let's create a variable called upper left, and the variable type here will be a target point object reference. To be able to set that from within the editor, we'll make it instance editable and expose on spawn, and then create another variable of the same type called lower right, and same settings, so editable and exposed on spawn. We want to update the position of this actor in real time, for example when we move the corners. So the place for our logic will be the construction script. And first off, here we can't do anything if the upper left or lower right target points are not valid. So let's drag in upper left and check for is valid. So did we select something? And if it is valid, we have to do the same thing for lower right. So again, call is valid. And then hook that up to the pin. If both of them are valid, we will set the position of this actor to the center of the world. So we will use set actor location of our cells, and we will just teleport. For the new location, let's make a vector. X and Y we can figure out with our two target points. However, we don't really know about the Z. So let's just say that the Z of this will be able to be modified and only X and Y depend on the lower right and upper left corner. To do that, you simply get actor location of self and break it. Then hook up the Z to the Z of the make vector node, right? So Z won't be changed from the construction script here, but X and Y will. To figure out the center of the lower right and upper left corner, we get upper left, get actor location, and we want to add something to this. So hit the plus vector, and basically we want to get the vector between upper left and lower right, divide that by half and put that in here. So that way we will get the exact center. Get your lower right, get actor location. Then we will subtract from that and hook up the actor location of upper left. Then we will divide that vector by a float, which will be 2. So that way from the upper left corner we only go half the way to the lower right corner, and that way we end up at the very center. And then plug that in for your add node. Then we want to break the result, because like I said, we only care about X and Y, and just plug that in for the make vector. Apart from that, I told you that we need to update the ortho width of that scene capture component so that we're able to see the whole world. To do that, get your scene capture component and set ortho width. We'll be asking you for a new value. The new ortho width has to either be the height of our world or the width of our world, based on which of these values is greater. And that way we can fit the world into a texture of a square shape, because like you see, we can only modify the ortho width and not the ortho height too. We already implemented the logic for getting width and height in the first episode. Get your lower right target point and get actor location, then break it. Let's take the X and we want to subtract from that. Copy over your upper left corner and the actor location break nodes. Hook up upper left as the target, then connect the X to the subtraction, and after that call absolute. So right now this would be the height of the map. If we do the same thing for Y, so Y minus the Y of upper left, and also call absolute, this here would be the width. And then we will just call a function named max float, hook both absolute nodes up and connect the max to ortho width. Save. That is everything for the logic of this BP world capture. We can close it and let's drag one world capture into our level. Let's move it up in Z by a bit. We'll be asking you for upper left and lower right, so let's select these two target points. If we then save and just move your actor, you will see that it will snap to the center here. And if you select the scene capture component, you see that the ortho width is set to 5900. If you've watched the last episode, you know that this is the width and height of the whole level. So that also updated perfectly. Let's see whether it also feeds into our texture. So go to your world map system, render target and the world render target. Let's open that up. Alright, you can see that our level is rendered perfectly here. This is an accurate real-time representation of our world. You also see the animations of the water material. Let's close it. For the texture to export, we don't need it to permanently update and recreate the visual effects. So let's simply right click it. And here you get an option that is called Create Static Texture. Let's hit that. And now you've got a static representation of that without the water animations and so on. Right, we can also close that. Let's hit F2 and rename that to something like Captured World Texture. And we've completed the first step of our plan to render a top-down image of the world that is completely accurate. Now we'll try to export that. So right click, go to Asset Actions and hit export. Then you can give it a name. For me, Captured World Texture will work fine. And you see that the type of it is a target, a .tga. This is the default file type that Unreal uses for textures. And you should be able to open that in most of the image manipulation programs. If not, you can export it. And on the internet, you will find websites that will convert TGA to PNG or JPEG for you. Once you've given it a name, you can simply choose a location. I'll use the desktop and save. Now you can open up the image manipulation program you want to use. In my case, that will be Photoshop. Okay, I've loaded up Photoshop. The next step really depends on the program you are using. For Photoshop, you just go to File, Open, and then select the texture at the location where you stored it. So let me do that. All right, that loaded up fine. I'll double click the background here and hit OK, so it becomes common layer and we can later delete it. And then in Photoshop, I'll hit Control, Shift and N to create a new layer. Hit OK. On this layer you can simply draw over your map without losing anything and create the world map you want to use. My plan here is to make a transparent map, so remove the background and only show some white shapes for the platforms, which means I will just use the pan tool here and create shapes for all of the platforms of the level. Alright, I'm done recreating the shapes of the platforms. Now to give all of them the same look, I'll just select all of them using the Shift key and left clicking and hit Ctrl G to group them. Then I can double click the group and give it a color overlay and select white here. Then I'll also give it an outer glow and select black as the color. The blend mode should be normal. I'll increase the opacity and the size of it. Then I can remove the background and just reduce the opacity of the whole group to something like 70% maybe. Yep, that looks fine. Once you're done drawing your map, you need to export it as a PNG or JPEG if you don't need transparency. So simply go to File and Save As, give it a name and location, then drag that into your textures folder of the UE4 project, and I'll see you once that's done. I've simply called mine the map image, and back in our UE4 project I can open that up. Compression should be user interface and texture group UI. Then hit save. To display that we need widgets, so let's head back to our world map system folder, add a new folder for widgets and go in there. Then we will first create a sub widget for the map and later put that in a main widget. So right click, user interface, widget blueprint, and let's call that W_world map. This widget will be nested inside other widgets, so you can set the setting here to desired on screen, and we don't need a canvas panel. We want to start with a size box, and this actually has to be a variable, so let's call that map size box and check the is variable. Because later when we are zooming in and out, we need to modify the size of it. Let's check width and height override, and by default, let's say it's 1080 by 1080. In our map size box, we need an overlay. And let's call that map overlay, also make it a variable. If you've seen the showcase of this system, you know that the markers appear on top of the map. That is why we need an overlay, so we can put other UI elements on top of the map. And the first element in here that we need is simply an image. Drag that onto your overlay. Let's call it background. we will make it fill horizontally and vertically. And under brush for the image, let's look for the map image or whatever you call your version of it. That's it already for designing this widget. You can compile and head over to the graph. I already told you that the size of this widget will be dynamic for zooming in and out. So let's create a variable called map size x. Let's make that an integer. And also editable and exposed on spawn. Then do the same thing for y, so map size y, editable and exposed on spawn. The last variable that we need is the actual texture of the map. So let's hit that variable button once more and call it map texture. Type here will be texture 2D, object reference, also editable and exposed on spawn. To set up the default values of all of these variables, we need to compile and save first. So map size in X is 1080 by default. Same thing goes for Y. And the map texture will be our map image by default. Let's add a function to modify the map size and to update the map size box to represent the two values. So let's add a function called setMapSize. This needs two inputs. Both of them are integers. The first one we will call 2x and the second one 2y. Before we do anything with the size box, let's simply set our two variables to the matching inputs and hook them up to the execution chain. Then let's grab the map size box and let's set width override, and directly after that set height override. Hook all of them up and simply drag in your variables, so map size x, hook that up for width, and then do the same thing for y. After that we can go into a return node, and that's it already for this function. So compile and save, close it. To make this widget update in the editor, we want to use the event pre-construct, and we can remove the other two. First off, we want to set the map size to the default values of the map size x and map size y. So this simply means updating the size box to match the two values. And then after that we can get the background and set brush from texture, hook up the map texture and connect it to setMapSize node. Last thing we want to do here is let this widget know about the world map component that is created for. So let's add a variable called mapReference, and the type for that is a BPC world map object reference. You can also make this a private variable. And then we want to add one custom event to set this variable called initialize. Give that one input, call it map, and same variable type here, so BPC world map reference. The only thing we want to do here is set our internal variable to the input. All right. If we were to head over to the designer, of course compile and save, and select the W world map in the hierarchy, we could play around with these values and see it updating in real time. So let's set these to 500 by 500. See a much smaller version here. And if we were to play around with the map image, for example, choose the icon player, you can see that now that is displayed as the map. It doesn't really make sense. So let's reset that to the map image and size of 1080 by 1080. Save. Let's put this world map in a main widget that we then add to the viewport. So let's close it. Add another user interface widget blueprint called w_main and open it up. If you then expand the category user created, you get your W world map. Let's drag that in. And we need to access this later. So let's simply call this variable world map. We need to put it in the very center. So use the center anchor, an alignment of 0.5 in X and Y. And if you use the alignment, you can set position to 0, 0. And that way it will be in the very center. Let's also check size to content. This way, if we play around with the values here, we'll also update in our main widget. We will increase the Z order to something very high, like 10. Just in case you ever put other widgets in here, the map should be drawn on top of these. And that's it already. You can compile and save the main widget, then close it. The only thing left would be to create this main widget and add it to the viewport. Let's do that from within our world map component. So actors, BPC world map. We already got the initialized map event. Let's go ahead and create widget. Select the main widget. We want to store that in a variable, so promote to variable main reference. Let's also keep track of the world map in there. So we will get the world map and promote that to a variable called map reference. Hook that up to the execution. Off of your map reference, you need to initialize this. It's asking you for a map, so that is self. And after we've done that, we only need to show the main widget. So grab the main reference and simply add it to the viewport. We can compile, save, close this component. And if we were to hit play, we can see that our world map is displayed in the very center of our screen. Alright, that's it for this episode. In the next one, we will deal with displaying the player on the map and updating his position when we move around and jump and so on. So, see you then.